All right, hello. Welcome. Today I am just going to be showing a repo I made today, which shows how to use pgvector with Postgres from Python. And I made this because I'm actually quite new to pgvector, and so I'm just trying to go around and figure out the different ways to use it, and especially how to use it from Python, how to set it up, all of that stuff, so that I can learn better how to use it. The ultimate goal is to be able to use pgvector on Azure with the Azure Postgres servers. So I'll be setting that infrastructure up soon. But for now, all of this is stuff to play around with local Postgres. So this is the repo, and I just made it like an hour ago, so you can check it out here, Pamela Fox pgvector playground. And that's what I'll be going through. So I've already got this open in a code space. So starting off, let me switch so you can really see this. So this repo is set up with a dev container, and the dev container makes it so that this repo, when you start it up inside GitHub Codespaces or in a local VS Code dev container, it will actually create a Postgres database inside that container. I always do this when I'm working with databases because I hate setting up local Postgres databases. So I like to just have it always set up. So that is set up via this Docker Compose file here. So this is in the .dev container folder. So this Docker Compose composes together the database with the just the rest of the code. So the database is this one here. So this is what you might see and also in a Docker file. So we are using the pgvector image. Now normally when I set up a Postgres playground, I use the Postgres image. So I actually started off modifying my my Postgres playground. So I do also have this Postgres playground and a SQLite playground. I have so many playgrounds. I love playgrounds. So this one, we can contrast it. Actually, another way of contrasting it is that I actually started this whole repo as a branch on this one, but then it was just so different. So here you can see the image is Postgres, right? So really the only change I made was that I changed the image to pgvector. So pgvector is an image that's based off the official Postgres image, but it always has pgvector installed. So this is what looks like to be the recommended way to build a pgvector database image right now. You can also actually write a Docker file that pulls from, Postgres latest and then brings in pgvector and installs it manually. That's also an option. But this seems to be the most suggested way of doing it these days. And I found that from the pgvector repo. So this is the plugin for Postgres. Now this repo here is not Python specific. This is just pgvector for Postgres. And if you were going to build it, I don't even know. Oh, it's in C++. It's in C, I guess. Yeah. So that's, I guess, the Postgres extensions must be built in C, or at least this one is. So I got instructions. There's lots of instructions for how to install. And here's the Docker instructions. So that's what I used, was this pgvector here. And we can change the version if we want to use a different Postgres version. And we could also build it here. So yeah, so we set up this pgvector here, and we set it up with this. This is all just local. So this is all local credentials, right? This is not the Docker Compose I would use in production. This is to create a dev container, which I can use to open GitHub Codespaces or VS Code with the dev containers extension. So we've got that set up. I think my Docker file is my Docker file is just pulling this dev containers image and then adding the Postgres client to it so I can use PSQL. So if I went here, I haven't even tested that. Yeah, I do have the PSQL command, and that's because I did build that into this Docker file here. So that's also something you might want to do when creating a dev container for pgvector. All right. And now what do we got? So the whole point of this is to play around with pgvector in Python. So what I found was that pgvector, the GitHub organization, has this pgvector-python package, and you just install it with pip install pgvector. So I've got that in my requirements.txt. You can see there's pgvector here. And now the documentation for pgvector Python shows how to use it in lots of different common, ORMs and database connection layers. So Django, SQLAlchemy, SQLModel, SQLPG3, SQLPG2, asyncpg, and pwe. So I ported almost all of these to the Playground repo. I didn't port Django because Django's a whole big thing to set up. Then I didn't want to put a whole Django app inside this repo. And I didn't port pwe just because I've actually never heard of it. So I would need to look into why, what is the advantage of using pwe and why people use it. It's got a great name. Okay, so we brought in pgvector. So then we had to decide, what layer are we going to use on top of it. So you could start really low level. So let's start low level just to show you the SQL statements. So I'm going to go to my examples and we'll start at psychopg2. So this is psychopg2 code. So I'll make it real big here. Okay, so we start off with just connecting to the local database. And I store all this inside of .env. So you can see my DB host is localhost, DB user is admin, DB pass is local password only. To make it very clear, this is not my production password. And DB name is Postgres. Now, all of this needs to match what is inside this Docker Compose. Because when you pull a Postgres image, you need to specify what's the default database, what's the default admin user, and what's the default admin password. So you'll notice that this matches this. So going back here. All right, so we got that all set up from the environment file. And then we set auto commit. And the first thing we do is create extension if not exist vector. So this is what installs the pgvector extension. And then I'm going to start making the table, right? So first I drop it in case it already exists, then I create the table. And for the embedding column, we specify it is a vector type. So this comes from the pgvector extension, this vector type. And we're doing a vector of dimension 3 for this example here. This is a very, very small vector, not a practical size of vector, but it's a classic size to use when you're just demonstrating vector embeddings. So we'll use this vector of size 3 for the example, this example. And we also need to call this register vector. So this comes from the pgvector psychopg2 adapter is register vector. So that is going to make sure that the vector connection really works. Then we can create an index. So pgvector comes with 2 different indexes. One is HNSW, which stands for hierarchical, navigable, small worlds. And it's a very cool index. There's lots of videos out there that show, that explain how it works. It's pretty interesting, actually. And then the other one is IVF flat. And I actually haven't read as much about IVF flat because HNSW is a little more common these days. So I've been binge watching a lot more HNSW than IVF flat. But I need to learn about that one too, because basically these are the 2 most common ones that you'll see supported in vector search offerings. So I went with HNSW. All right, so we create the index and I tell it what it's going to index. It's going to index the embedding column, and I tell it what the distance calculation function is going to be. There are 3 options. It's vector L2 ops, vector cosine ops, and what's the final one? Let's see. And vector IP ops. Okay, so they're basically the 3 different ways that you might want to calculate distances between vectors is L2, which is Euclidean, IP, which is inner product, and cosine, which is cosine distance. So for the simple example, I went with L2, but when I move to using eta, I'll actually change this to cosine. Now we're going to insert items into this. So when you're working with psychopg2, you actually have to use NumPy arrays as the data type for embedding, because that's how it knows what operators it can use on them. So originally, actually, I used a list of floats, and then I got an error when I got to this stage. So we do need to use NumPy embeddings here, NumPy arrays as the actual values. So I've got a list of NumPy arrays, and I insert each of those in. Now I can actually start doing some vector operations. So the first thing we want to do is find the two closest vectors to a target vector. And this is basically vector search. So like if we were doing an AI application, we would take the user's question, turn it into a embedding vector, and then we would find the closest results to that embedding vector. So this is the most classic thing that a lot of people are interested in these days. So we say select star from items, order by embedding. And then this is the special operator, which means do L2 distance. And we can see that on here. Yeah. So this is the L2 distance operator. And then the inner product is with a hash sign. And the cosine distance is with the equal sign there. So you have to pick which operator you want to use based on how you want to calculate that distance. So we order by the each rows vector, the distance of that to the query embedding vector. So it's going to go through each of them, figure out the distance, get the closest ones, limit it to 2, and then return them. Let's just run this actually. Okay, so you can see that gave us these two vectors here. So these were the two closest ones. The next thing we can do is calculate the distance. So here you could, actually run that distance computation in your select if you wanted to actually get back the distance for whatever reason, like for search scoring, you could put that in your actual select. So there we can see the distance between the query vector and the very first row is 2.44. And now we could also find all the vectors whose distance is under a certain threshold. And this can be useful to do because here's the tricky thing about when you're doing vector search is that a vector search will always return results if you're doing this, right? Because you're saying like, oh, get me the 5 closest, even if the 5 closest ones are really, really far away. That's different from when you do like a full text search. A full text search, if it can't match, if it can't match text, it can't match the text and it's going to give you nothing back. So you do need to think about thresholds when you're implementing vector search. So even if you do something like this, you may still want to have a threshold either in your query or in the client that gets it back that says, okay, well, yeah, we got back the 2 closest, but they're still really, really far away. And part of that also is figuring out what does it mean to be far away? Like what is a reasonable threshold for closeness? And that takes some experimentation. It's going to depend on the embedding model, and it's also going to depend on the domain. So you may end up wanting to do something like this where you're saying like, well, it has to be within a certain distance, right? So we're saying, okay, where the distance is less than 5. And so that in this case gets the same one. Let's see if we do it less than 2. I don't know if it'll get back any, it's going to get back any results. There will get no results, less than 3. They might both be really, really close. I didn't actually calculate the results. Oh, I think that time I got 1 result. There you go. So less than 3. So that's an interesting one. And then we could calculate the average of all vectors. That's just to show that they do have this aggregate function available, average embedding. And I don't see myself using that much, but it might be useful if you've got like a bunch of stuff chunked up that are related and you're trying to make an average vector from them. So kind of try and turn them into a single item in a way. And I do think that is how sometimes people will implement, coming up with embeddings that represent larger items. So there we go. Okay. So that is the SQL statements for working with pgvector. Now, a slight variation on that is asyncpg. And this is actually my first day using asyncpg, but I really like the idea of it because it is an asynchronous driver for Postgres. We can look at their PyPy because they actually have some cool graphs on it. So it is built on Async.io from Python. And it has these benchmarks here where it says it is 5 times faster than PsychoPG3. So that's pretty good. That's pretty fast, but also just generally, it's nice. It's a good idea to try and move towards asynchronous, libraries and interfaces when we're doing operations that potentially could take a long time. Because when we deploy these sorts of, database using apps onto servers, then we can benefit if we're using asynchronous APIs, we can benefit more from concurrency. So when the database is going off to make a network request, they can start to handle the next user's request while they're waiting for the results of that database request. So I am trying to move towards async when possible. So I made this example using asyncpg, and it's really similar. It's just the asyncpg functions are a little bit different, and we have await in front of a lot of these things here, right? Await the results of all these execution calls. And also at the very bottom, we have this get event loop run until complete, because we have to run everything inside an async event loop. The SQL itself is pretty much the same, just a slight difference in the string templating that it uses. So we can run that and we should get the same results. Okay, now most of us use an ORM. The most popular ORM for Python, I believe, is SQLAlchemy. It works with lots of different engines, so lots of some drivers. So not just Postgres, it'll work with MySQL, SQLite, all of those. And it's a really well thought out package. It's got a lot of support, and it recently added, in the last year, added support for Python type annotations so that your IntelliSense and your type hints will work. And that was really exciting when that dropped. So here we have the same. This is going to be the same thing. This, just this very simple 3-dimensional vector. But here's how we define it in the SQLAlchemy ORM. So we say, okay, the table is going to be named items. The ID is an int, and it's the primary key. And there's going to be an embedding column, and that is a vector. Then we connect to the database, same as before. We create the schemas that creates the tables. And now we can start issuing some queries. So we have to create that extension if it doesn't exist. We need to create the index if we want to use an index. So you don't actually have to make an index. You could just not make an index, which means you'll be doing an exhaustive search every time, which would, of course, totally work for our database here, which has 3 rows, our table with 3 rows. But once you start to move to having, thousands and thousands of rows, you're going to want to index for better performance. So here, when we create the index, we can say, okay, we're using HNSW. We can give it classic HNSW parameters like M and F construction. Once again, there's great videos on YouTube that talk about these and show the effect that they have on the performance. And then this is really important, is we're telling it, what operation to use. So we're telling it to use that L2 operation, Euclidean distance, not cosine distance. So there we go. We create the index. Then we add our default embedding vectors. And then this is all just the same code, but via the ORM, right? So we can see here that we have an order by, and we say, okay, you're going to do item.embedding.L2 distance. So it's going to order by these L2 distance between this vector and each of the rows. And we use that again here to calculate the distance. Again here, but less than 5. And then for average embedding, we do func.average. So it's the same queries I just showed, but ORMified. Now we can run that, and ta-da, it works the same. Now, once again, I'm very interested in asynchronous usage of APIs, and SQLAlchemy does support using it asynchronously. And this is actually my first time using it asynchronously. I always knew that it worked, but I thought this was a good excuse to try it out. So I started with their example from the documentation, which was great, and then modified this. So all of this is the same here, but we do bring in some more imports. So we're bringing in from SQLAlchemy.x.async.io, which means actually in order to get this, I did have to bring in SQLAlchemy bracket async.io. So it is a slightly different requirement. It's because it's bringing in more packages, potentially more code. So you do need to bring this version of SQLAlchemy in if you do want that async support. So we bring that in. We've got async session maker, and create async engine. And I think the rest are the same. We also have this import async.io. So this is the same. Now we wrapped these in functions. This was part of the default example, and I figured I would stick with it because it's probably a good practice, because a lot of what the document tries to emphasize, the documentation emphasizes that your sessions should be like, you should be using one session per, like transaction, per database transaction, right? So this is basically I'm using one session to add all the items. And then I have another session here for, selecting objects. And I think that makes sense because a lot of times adding the objects is going to be a different thing. So I thought these did make sense as separate functions. And so you can see in each of these functions, they use this session maker, and they use that to make a session, and they're using an asynchronous context manager, which is a really good practice to do. A lot of times you have the option to not use an asynchronous session manager, but then you end up having to later do like session dot close, that sort of thing. And if you forget to do that, then you end up with all these, errors when you try and close out your server or your script that says, oh, you have an unclosed session. So is always nice when you have the option to use a context manager. It's a good idea to use a context manager. So this even uses two context managers in order to get into the session. All right, and then down here, we've got the query function. So this is really similar. It's just that we're using the session. And then down in async main, we create an async engine. So that's slightly different, where we're specifically creating the async engine. And then we create the async session using the async session maker, using the recommended parameters here from the documentation. And then we have this async with engine.begin as connection, and then it runs. It actually runs. So this is if you need to run synchronous commands. So apparently drop all and create all is a synchronous operation. So you have to use run sync for that. And then we can, await our insert call and our select function here. And then finally we dispose. So that's how you do it with async SQLAlchemy. I still don't 100% understand exactly every line of code there, so I probably need to reread the documentation one more time. But I was able to get it set up pretty well. So I think this is probably what I would use inside an application for, like a court asynchronous application, or even a fast API application. So that does lead me to my next example, which is SQLModel. So SQLModel is created by Sebastian, who created Fast API. And it is what he, recommends for using with Fast API because it's based off pedantic models. And people who like pedantic models are, they're going to gravitate towards SQLModel. So do seem to be a lot of people using it. I tend not to use SQLModel because it is actually a wrapper of SQLAlchemy. And I find that you get the type annotations don't work quite as well, because the whole point of the latest SQLAlchemy is to give you really, really good type annotations. But if you start trying to wrap SQLAlchemy in other libraries, it's really, really hard to get those type annotations to work really well. So I can show you by example. If I run MyPy on the SQL model one. Let me install MyPy. I think there's one actually built in that I can just run into the dev container. So we'll run it on there. It takes a few minutes, but it's going to come back with a typing violation because it doesn't understand this embedding column. It doesn't realize that this embedding column can have an L2 distance function on it, right? So you can see all these things. List float has no attribute L2 distance. And that's what we have this set to here. So there might be some workaround. We're trying to figure that out if there's some workaround so that we can get good typing for when we're doing these vector fields with SQLModel. Maybe we'll figure something out. But that's why generally I tend to try and stick as close to SQLAlchemy as possible, or just use SQLAlchemy models because that's my best chance of getting really good typing, type checking. But anyway, so here's the SQL model code. So it's making a pedantic class. And here I had to use this SA column quargs. So whenever you're doing something that's not quite default in SQL model, then you use this SA column quargs or SA column, which means SQLAlchemy column quarks. So this is how I passed an auto increment true. And then this is how I let it know that, hey, this is actually a special column, which is the vector type. So I had to do that overriding there. And then I can add it. And then this code looks really similar to our other code. They tend to, pretty much do the very close to the SQLAlchemy way of doing things. It's just really the model here that changes quite a bit. And there we get the same results. All right. So those were the basic examples. Now I want to show storing some ADA002 embeddings. So let's see if I can open this without completely destroying the browser. All right. So it's a very large file because I've got all these Disney movies in it, and they're all embedded with ADA002, which is the classic OpenAI embedding model. There's now ADA3 models that I need to try out, especially because I can make ADA3 models can vary in embedding size between 256 and I think 3072. So if you wanted to like really save space, you could go for that 256. And apparently they claim the 256 can encode just as much as the ADA003 does in it's 1536 it has here. But anyway, so these ones have movie title and then the vectors, which are 1536 floats long right now. So that's what this JSON file has. So I already pre-computed these vectors. And so here is my code for using SQLAlchemy with them. So I have the movie class, and I'm going to have an ID. I'm going to have a title, and I'll have the title vector. And that I set the vector dimensions to 1536. And then I connect the same way as always, create the extension, create the index. Now this time I am using vector cosine ops. This is because cosine distance is generally what you should be using with the ADA models. I don't know the exact math of why, but it is always what's recommended as the distance metric when you're using the ADA models. So I specifically set that there. Create the index, open the JSON. For everything in the JSON, I add it to the session. Then I query the database. So what I'm doing is looking for the movie Winnie the Pooh. And if there's any movie you want me to query, just put it in the chat, John, or whoever else is watching. So here's where I query the movies. We're just going from Winnie the Pooh here in classic at our household. And I'm going to find that movie. And then I'm going to try and find the 5 most similar movies to Winnie the Pooh. So I do select movie, order by movie.title vector, cosine distance. So there we're doing cosine distance instead of that L2 distance from before, to cosine distance to the title, the target movie's title vector, limit 5. And then we print it out. All right. So here are the most similar ones to Winnie the Pooh. Now, John suggests Frozen 3. Now, here's a question. Is Frozen 3 in my database? Now, the thing I haven't shown yet is that I do have this awesome SQL Tools extension in here. And SQL Tools is super cool. It's a VS Code extension, and it gives you like this little UI for going through your, your database. And so you could use this. Oh, they've got a little filter here. Okay. So they do not have Frozen. They don't have any Frozen. This must be an old one. What would they have before Frozen? They have Fantasia. I'll do Fantasia until I get another. So I guess we got to go for classic ones because my data is not up to date. So I'll go and run that. Cinderella. Yeah, we can definitely do Cinderella. So Fantasia is very similar to Fantasia and Fantasia. It's doing good. But also to Aladdin and Enchanted, which makes sense. They're kind of fantastical. I would have also accepted Heffalumps. So let's do Cinderella. We can also double check here that we have Cinderella. There we go. We got Cinderella, similar to Beauty and the Beast, Sleeping Beauty, Aladdin, and Waking Sleeping Beauty. Didn't know about that one. So that makes sense. It's similar to classic movies. Now, these are encoded just the titles. I've only encoded the titles, and this is with the Ada model. So you don't know what's encoded in just a title, right? Some of it is spelling, some of it is pop culture, right? So you know that in pop culture, Cinderella, Beauty and the Beast, like they're very close to each other, right? They're both princess movies that came out, basically when I was young. Um, but then we also see similarity, between, just like spelling, like Sleeping Beauty and Waking Sleeping Beauty, right? So it's pretty interesting using the Ada model to try and imagine what's in its head, like how it's encoding things. So yeah, good question from John. Who is calculating the embeddings for the query input? So in this example here, I'm basically doing like a recommendation engine, right? So I'm only doing movies that already exist because that way I can get back the query vector. What we could do is, since you asked, we can go and calculate an embedding on demand. So let me find, I usually have something open that I can use for embeddings. Let's see. Vector. Okay. All right. So let me see if this one is working right now. What library am I using? So if we wanted to like take arbitrary input, right? Because John wants to ask about Frozen 3, we need to get the vector for that. And my repo right now doesn't have anything to do with OpenAI. So I need to actually calculate that vector. Oh, but I'm not like logged in properly. Let's see. Let's see if I can log in real fast. Maybe we can also just go to, does OpenAI have an embeddings playground? So I do have an OpenAI account. So let's see, API, because I just need to calculate a single embedding. So let's find out. Do we have playground? No, there's no embedding playground. Really interesting. If you know about an embeddings playground, let me know. All right, authentication complete. Now let's try it. All right, 400. Let's see. So 400 would be, that would be, okay, probably I've been messing with, oh no, don't look at my key. That's a problem with keys. There's a tokenization playground. Yeah, there's a tokenization playground. That's not unless that gives embeddings, that isn't gonna have the embeddings. Where I just need to find one where I'm properly logged in. Probably over here. Let's see. And I really should be able to do this faster. So let's see. So we need an endpoint. All right, so let me get an endpoint. I'll just hard code the endpoint to one that I know is working. That one I did something special with. Okay, I'm always messing with this as a problem, but let's get an endpoint. Here we go. That's an endpoint. All right. And then we need the employment is going to be called, it's called embedding. Okay. All right, that one should be working. Just try it out. What is up with my tenant? This is one of these funky Azure ones. All right. Just gonna log out. Log in. Let's see. And 400. What is going on? All right. Where else do I can go and grab it. I'll just grab a key. We'll just make a key and then we'll delete it. Delete this after stream. Okay. And now I'm going to change this to OpenAI and API key. And I'm going to put it in here. Although you can see that anyway, so I have to delete everything anyway. This is why you shouldn't use keys. Okay. And all right, do OpenAI key. And is that going to be enough? Let's find out. Model. Yeah, we'll do model would be text embedding. Let me get the name for it. Text embedding 002. Okay. All right, so we gave it our key, told it the model. Not actually using the Azure stuff. Let's run this. There we go. Wow. All right. I need to be better set up to be able to do embeddings on demand. So you can see this is beautiful. So this is what a really big 1536 vector looks like. And now we can go back over to this one. Oh, and we want not dog, we want frozen 3. Okay. So I'm going to go ahead and generate the vector for frozen 3. And then go and copy paste this. I do love the white space. It looks like a scrolly. Boop, 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 boop. Okay, was this it? There we go. All right. And then we're going to go over to the playground. And so now the target query vector, we'll do this, is going to be this. Hopefully it has a square bracket at the end. I can't tell. Don't copy and paste really long vectors in your code, people. We're going to replace this here. Okay, there we go. Okay. So what we got was Toy Story 3, Iron Man 3, Frozen, Ice Princess, and then X Games 3D, the movie. So that's really interesting because it definitely put a high amount of emphasis on 3, right? It thought that Toy Story 3 was more similar to Frozen 3 than Frozen itself. Part of that might be that, wait, Frozen 3 doesn't even exist. Yeah, we did get Frozen, but Frozen 3 does not even exist. So we had it in like generated embedding for a movie that doesn't exist. So what if we generated it from Frozen 2? I don't think it doesn't exist, right? We watched Frozen and Frozen 2 this weekend because we went to Disney on Ice. And I'm pretty sure Frozen 3 doesn't exist because I feel like I would know. Now there is, of course, the Olaf Christmas special, which is a classic. But not Frozen 3. So I want to know, I want to see if it actually ends up being more like, you know, better aligned when we give it a movie that exists, right? Because then that would have some, you know, pop culture knowledge in it, perhaps, depending on when it was trained. Okay. You know, I think I should be able to just like stick this in my clipboard more easily. All right, so we're going to go in here, replace that beautiful line, and run this. And this time we got a bunch of 2s. So that embedding is really prioritizing 2s. That's super fascinating to me. That once again, Frozen was you know, ranked so low down. Now, this is actually a good point because this can be one of the issues with vector search is that, you know, it doesn't always do as well when you're trying to get more exact queries. So what's generally better is use hybrid search. And I discovered that there is, if you go to the pgvector Python examples, there is examples of hybrid search. This is a lot more complicated, so I didn't try it out yet. And it's got the sentence transformers. Okay, but it is doing, so here, where does it do the keyword search? Okay, so this is like doing a full text search in Postgres. I haven't used any of these things before. Plain 2 TS vector, plain 2 TS query. Okay, so that does the keyword search. And this does the vector search. So that's what we were just using. And then, so it does an async IO gather of semantic search with keyword search. and then it does a re-ranking, and it actually uses a model, this cross encoder model, in order to run a prediction on the results and re-rank them. So this is super interesting. So if you do want to do hybrid search, take a look at this example in the pgvector Python repo. And there's one more example as well, hybrid search RRF. And I know about RRF because we do use it. So Azure AI Search is from Azure, and it supports hybrid search. And the way it does use reciprocal rank fusion. So this RRF is common, both in industry and, well, pgvector is also industry, but both in open source and not. All right, so the RRF example here, we've done, so does the vector search, it does the keyword search, and then it's using the coalesce operator to compute the compute results for it by doing this math here. So it's described, they do describe it here if you want to get an explanation of RF. I'm sure there's other explanations as well, since it's something that anyone can implement it. And it's a really interesting thing though, how do you combine results from vector search and keyword search? Because the thing about is that they're very different, right? So when we're doing a vector search, we're calculating this distance, cosine distance using a particular model. Like in this case, it might be, it's eta 003, but maybe we'd move to eta 2, or sorry, eta 2 to 3. But there's many other embedding models, right? And they all going to have slightly different like distance characteristics. And then full text search is using a completely different scoring algorithm. So in the case of Azure AI Search, it uses this VM25. In this pgvector examples, I'm not really certain. I'd have to look into this TS vector, how it works. But how do you combine results from these two very different ways of searching? So that's what this RRF tries to do. So that's super interesting too. So I'm pretty excited about this, and that's why I'm playing around with this and why I made this repo here. My next step is that I want to do a fast API app that makes a vector search endpoint using pgvector with Postgres, deployed to an Azure Postgres server, and support options like hybrid search. I think that would be really fun, and also really quite useful for all the different applications people are making these days, right? Especially with all the RAG applications, which I love to make. So yeah, that's it. That's all I wanted to show today. Thank you for hanging out. I don't know if there's any follow-up questions, but the links, I'll make sure they're in the description. But we've got the pgvector playground repo. We've got the pgvector repo for how to install pgvector into Postgres. We've got the pgvector Python repo, and this was a huge help because most of my code was taken from here. All those item examples was taken from the documentation here. I just wanted to get it all working in single file so that I can just run them, put a little CI in them, and there you go. Okay, so let's see. Question from John is, will you use a container on Azure to run the PyVector image? Yeah, so that's a good question. How am I going to run pgvector? So I was going to use, we've got a couple different ones. We've got Azure Cosmos for Postgres, which is really Postgres with the Citus extension. So it's like highly scalable Postgres. So it's a good fit for Azure because Azure is pretty good at scaling things. So this does have pgvector support. So I should be able to use this. The one I'm more familiar with, so that's what I was going to start with, is Postgres Flexible Server, which does have pgvector support. It also has this new extension called Azure AI, which would actually calculate the embeddings for you. You know how much effort I just went through to calculate that embedding? I could use that to the Azure AI extension. However, currently it only works on the actual Azure production server. And right now I'm trying to get things working well locally. And I'm trying to mostly use things that I can use on a local Postgres server. Because when it comes to databases, I usually, when I'm running locally, I want to run with my local database, and I want to make sure I do not mess with my production database. So I will try very much not to touch it. But they do have, let me see, where is there? they have this new Azure AI extension. There we go, integrate Azure AI capabilities. So they're really trying to make it, super easy to do AI stuff with Postgres. So in addition to pgvector, you can set up this Azure AI extension, and then what you can do is actually you could calculate the embedding right here, right? So Azure AI.create embeddings, that would create the embedding for you right there. So this is really cool. I've asked them to open source this, so I'm hoping that the extension will go to open source so that we could use it in our dev container, because I think that would be really nice. There is a third way of hosting posts. Well, I guess even there's a fourth way, but there's another way to put Postgres on Azure, which is Postgres for Azure Container Apps add-on. We'll see what they call it right now. Yeah, they kind of call it an add-on. So there's various add-ons you can put onto your container apps, and Postgres is one of them. And this is kind of like a built-in, so they've got like add-ons like for you can see the add-ons. We've got Kafka, MariaDB, Milvus, Postgres, Quadrant, Redis, and Weaviate. So it's like a sidecar container that can run alongside your container. However, as last I checked with them, it doesn't support pgvector yet. So I asked them like, hey, can we get pgvector in here? That would be really nice. So I'm hoping they're going to add it onto here because it's a nice little thing. If you don't need a lot of scale, it's not designed for scale. This is the least scalable, is this add-on. But, if you're making a little prototype or whatever, it's fun to just use the little sidecar. I guess the fourth option would be what John originally suggested was, will I use a container on Azure to run the pgvector? So yeah, I could do that. So I could, basically take, that pgvector image and deploy it. However, something to keep in mind is that I am not a sysadmin, and to run a database at scale is kind of hard. I mean, depending on how much traffic you're going to have. But if I thought I might have any reasonable amount of traffic, then I wouldn't want to be responsible for administering it and making sure it's scaling and sharding, distributed, all that stuff. So that's why I tend to use cloud services or managed databases, as you can call them. So I would tend to use one of these more managed database options, just so that I didn't have to deal with any sort of scaling configuration. But as an experiment, that could probably also work as well, to actually run it on a container and then you'd have to expose the container port, or you'd have to like set them up to communicate over a network. If they can, I think they can maybe communicate over their own network. So yeah, good thing to try out. All right, great question. So hopefully I'll be back with an Azure example to show. For that, I need to do a lot of bicep mangling, and that's not as fun to live stream. So I thought it'd be more fun to show this. All right, thanks everyone. Bye.